Okay, so for today, what I want you to do is pull out your multiple choice, the AB exam for 2013. And this is just a good review of all the different topics that you could be asked, okay, for any AP exam. So what I want you to do is you can complete all the questions. Again, you can complete all the questions and then watch the video and make any corrections. Or the other alternative is do question one, watch the video. Do question two, watch the video, okay? And go back and forth between watching the video and checking your work, okay? Either way, I'm fine with. I just want to see you doing the problems, okay? And again, when you do the corrections, just use a different colored pen or a different colored pencil, or if you're doing your work in pencil, then you do the corrections in pen, whichever. So I see two different colors basically, okay? And you can, I don't mind if you do your work in the multiple choice part of the text, or not textbook, but the multiple choice on the pages I gave you. I'm going to do them on binder paper, or actually my graph paper, but I'm absolutely fine if you don't use it on binder paper and just use the test booklet I gave you, okay? All right, so go ahead and pause the video and get started on the first. Well, actually, let me turn it. Okay, so we'll disregard this page. You can disregard this page, okay, and then we'll start on this one, okay, and I'll start doing the problems. All right, so go ahead and get your packet out and get started. Okay, for number one, all right, we are looking at the limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4, okay? And you should be looking at, okay, can you do a direct substitution, okay? So if you put 2 in here, that'd be 2 squared, which is 4, 4 minus 4, that becomes 0. And then 2 squared is 4, plus 2 more would be 6, and 6. So we get 0 over 0, right? Okay, so what that means is we can rewrite this, all right? So this becomes the limit as x approaches 2, okay, and there's a removable discontinuity here, okay? So this factors into x plus 3 times x minus 2 over, and then x squared minus 4 factors into x plus 2 times x minus 2, right? And there's your whole right there, right? Your removable discontinuity is at x equals 2. Okay, so this is equal to the limit as x approaches 2 of x plus 3 over x plus 2. And now we're going to be able to put it in, right? We can do a direct substitution now. Okay, so this becomes 5, because 2 plus 3 is 5, over 2 plus 2, which is 4. So the answer is 5/4, which is D, okay? You know, really, what I want to get you to practice in is just writing it out, okay? Because your communication of this is going to be important, because there's going to be no multiple choice, okay? So let's go, I'm going to slide it up and we'll go to number 2, okay? Okay, so for number 2, we have f of x is equal to x cubed minus x squared plus x minus 1. And I want to find f prime of 2. So first I have to find the derivative, right? So for number 2, okay, we got to find f prime of x. Okay, so that'd be 3x squared minus 2x plus 1, right? And then we got to find f prime of 2. Okay, so that'd be 3 times 2 squared minus 2 times 2, and then plus 1. So that means f prime of 2 would be 4 times 3, which that'd be 12, and then minus 4, and then plus 1. So then that means f prime of 2 would be 8 plus 1, which is 9, okay? And then that would be answer B. All right? Okay, let's turn the page and go to the next one. Okay, for number 3, we want to integrate 0 to 4 of x times e to the x squared dx. Okay, this is integration by substitution. So we're going to want u be x squared, okay, because that's going to make this e to the u, right? And we're going to be able to integrate e to the u, okay? So u is x squared, and that would mean du would be 2x dx, okay? So now what we need to do is replace this, okay? So we have the x and the dx, we need a 2 with it, right? So we can fix that by multiplying by 1/2 on the outside. So 1/2 times the integral from 0 to 4 of 2x e to the x squared dx, okay? And now this, the 2x and the dx becomes my du, and the x squared becomes my u. Now, these are x terms, so I'm going to need to switch these to u's, right? So this is 1/2 still. The integral from, okay, so we have to do 0 squared, right? 0 squared would be 0. And then 4 squared, and 4 squared is 16, okay? And then we have, this becomes e to the u, and then du, all right? So now, what's the integral of e to the u? Okay, well, and if you look, okay, wait, they just asked you to figure this out, right? And what the integral is, what would be the same value of it, right? So what we have is answer B, right? And that's all we have to do. Okay, all right, so question number 3, answer is B. We didn't have to actually work it out, okay? All right, so let's go to the next one. Okay, for so number 4, we have the equation x squared minus 3xy is equal to 10. Okay, and at the point 1, -3, and they're asking you to find the tangent line tangent to the graph, right? All right, so this is the point of tangency, so I have that. So to find the line tangent, I also need to know the slope. Well, to get the slope, I need the derivative, right? Okay, so I got to take the derivative of this, right? So the derivative of x squared would be 2x, right? And then dx times dx over dx, all right? And then minus 3 times, okay, and now this is the product rule, right? Because I have x times y. So the derivative of x would be dx over dx, or just 1, right? Times y, and then plus, okay, now I need the derivative of y, right? So the product rule is, okay, the derivative of the first times the second, that's what I have here, and then the first, which is x, times the derivative of y, which is dy over dx, right? So then dy over dx. You wouldn't have to have the parentheses. And then close the bracket, and then equals, and the derivative with respect to x of 10, well, that would be, that's just a constant, so that would be 0, okay? So this becomes 2x minus, and then this would be y, so I'm multiplying by 3, so minus 3y, and then minus 3x dy over dx is equal to 0. Okay, so what I'm going to do is I'm going to move these over to the other side. So I have negative 3x dy over dx is equal to 3y minus 2x. And then dy over dx is equal to 3y minus 2x all over negative 3x, right? And we want to find the dy over dx at the point 1 comma negative 3. Okay, so that'd be 3 times negative 3, because my y is negative 3, minus 2 times my x, which is 1, over negative 3 times my x, which is 1. Okay, so this would be negative 9, and then minus 2 over negative 3, right? So that'd be negative 11 over negative 3, which is the same as 11 thirds. Now, how I have you guys write it is y is equal to my slope, which is 11 thirds, times x minus 1, and then minus 3, right? Now, if you look, okay, the multiple choice doesn't have that, right? Because they moved this minus 3. This is the way I've taught it, okay? There's an alternative form for point slope form, and that's just moving the 3 over, right? So it's y plus 3 is equal to 11 thirds times x minus 1, okay? And so that would be answer E for number 4. Oh, let me slide that up. So answer for number 4, correct answer is E. All right, and this is about showing your work because, okay, because you're not going to have multiple choice on the AP exam this year, okay? Just free response. So writing it up correctly is going to be important, okay? Because if you write something that's incorrect, they're going to mark off for it, okay? All right. So let's go to number 5. All right, for number 5, they give you g of x is equal to 1/3 x cubed plus 3/2 x squared minus 70x plus 5. And they're asking for the intervals on which g is decreasing, okay? So to know where g is decreasing, you have to know where the derivative is going to be negative. So we're going to need to find the derivative first, okay? So let's do that. So g prime of x is equal to 1/3 times x cubed. So that'd be 1/3 times 3x squared, which would just be x squared. And then plus 3/2 x squared, the derivative of that would be 3x. So plus 3x. And then minus 70. Okay. And then what we want to do is figure out, okay, let's set that equal to 0. Okay, so we got to find the critical values. Okay, so we got to find where the derivative is either 0 or undefined. Well, this is a quadratic, so it's never going to be undefined. Okay, but it will be 0. Okay, so 0 is equal to x squared plus 3x minus 70. Okay, so this factors. Okay, and two numbers that multiply to give you negative 70 and add to give you 3 would be 10 and negative 7. So this is 0 is equal to x plus 10 times x minus 7, which would give you x is equal to negative 10 and x is equal to 7. Okay, now what these cause is this is where that x equals negative 10 and x equals 7 is where you have horizontal tangents, okay? Because the derivative is 0 there. And when the derivative is 0, you have a horizontal tangent. So you have horizontal tangents at x equals negative 10 and x equals 7. Okay, so what's happening in between these horizontal tangents, right? So you're going to make a sign chart, right? So remember doing this? You have the intervals. Okay, so you're going to go from negative infinity to negative 10. And then we're going to go from negative 10 to 7. And then from 7 to infinity. And then we're going to have a test point. Okay, so for our test point, I would use x is equal to negative 11. In here between negative 10 and 7, a good one would be x equals 0 and x equals 8. Okay, now down here we factored it, right? So I want to say this, okay, x squared plus 3x minus 10 is the same as x plus 10 times x minus 7. It's actually easier to calculate in the factored form, right? So I'm going to write this, g prime of x is also equivalent to x plus 10 times x minus 7, okay? So what we're going to look at is the sign of g prime. Okay, so when we put negative 11 in this first factor, right, that's going to give you a negative, and this one's going to give you a negative, right? So we're going to have a negative times a negative. And the negative times a negative is positive, right? Okay, and that tells you the behavior of g. Okay, and if it's positive, if the derivative is positive on this interval, that means it's increasing. Okay, and for x equals 0, well, if we put 0 into this first factor, that'd be 0 plus 10, so that would just be positive. You really don't care about the number value, you care about whether it's positive or negative, okay? And then you put 0 in here, and 0 minus 7, that'd be negative 7, so that'd be a negative. So we have a positive times a negative, which is a negative. Okay, what does that tell us about g? That tells us it's decreasing on that interval. And then from 7 to infinity, right? From 7 to infinity, we put 8 in, so 8 plus 10 is going to be positive. And we put 8 in here, it's going to be positive. And a positive times positive is positive, which tells you this is increasing, okay? So we know we're going to, and it was asking you where it was decreasing, right? So on the interval it was decreasing is negative 10 to 7, which is answer D, okay? And that's the answer for number 5. Okay, so I do think this is a good review, right? Because it goes over stuff that we haven't covered in a while, okay? So let's go on to number 6. So for number 6, they're asking you to find the integral from 2 to 4. Basically, this is 1 over 5 minus 3x dx, right? So this is the integral of from 2 to 4 of 1 over 5 minus 3x dx. Okay, and this is another, again, integration by substitution. So I'm going to let u equal to 5 minus 3 x, okay? And then du would be the derivative of this. So du would be, okay, so the derivative of 5 is 0, and the derivative of negative 3x would be negative 3. So this would be negative 3 dx, okay? So we don't have a negative 3 up here, right? So I can compensate for that by multiplying by 1 over negative 3. So this becomes 1 over negative 3, the integral from 2 to 4 of negative 3 over 5 minus 3x dx. Okay, so now, all right, this is going to be equivalent to negative 1/3, okay? And then these are going to become u values, right? Because this is going to be, this negative 3 dx becomes my du, so this is going to be 1 over u du, okay? So I'm going to write integral 1 over u du, and then these limits of integration become u values. Right now they're x, right? So we have 5 minus 3 times 2, and 5 minus 3 times 2, that'd be 5 minus 6, so that'd be negative 1. And then we put in 4, right? So 5 minus 3 times 4, that'd be 5 minus 12, which would be negative 7. Okay, and so this is equivalent to negative 1/3, okay? And then this is the natural log of the absolute value of u evaluated from negative 1 to negative 7, okay? So this is negative 1/3 ln of the absolute value of negative 7 minus negative 1/3, okay? So that's going to actually make this become positive 1/3, the natural log of the absolute value of negative 1. Okay, so this is equal to negative 1/3, the natural log, well, the absolute value of negative 7 is just 7, and then plus 1/3, the natural log of 1. Okay, now the natural log of 1, okay, we want to be able to evaluate this, right? Because if you look, your answers aren't there, right? And this is a correct answer, okay? It just, this one can be simplified a little bit more, okay? Because this is equivalent to negative 1/3, the natural log of 7 plus 1/3, the natural log, and 1 needs to be rewritten as e to the 0 power, because e to the 0 is the same as 1. Now, this is going to allow you to evaluate this, because natural log of e to a power, these are going to undo each other. You're going to be left with 0. So this is 0 times 1/3, which is 0. So what we wind up with is negative 1/3, the natural log of 7, or negative natural log of 7 over 3. Okay, so negative natural log of 7 over 3 is answer B, right? So that's our correct answer. Okay, let's go to 7. So 7 gives you the function f of x equals x cubed minus 6x squared plus 8x minus 2. And what is the instantaneous rate of change of f at x equals 3? That's all it's asking is, what's f prime of 3, right? Instantaneous rate of change means derivative, okay? So f prime at 3. Okay, so to do this, we've got to find f prime of x. So f prime of x is equal to 3x squared minus 12x plus 8. And so then f prime of 3 would be 3 times 3 squared minus 12 times 3 plus 8. Okay, so then this would be 3 squared is 9, 9 times 3 is 27, minus, and then 12 times 3 is 36, and then plus 8. Okay, and so I would combine the 27 and the 8 first, all right? So that makes 35 minus 36, which gives you negative 1. So f prime of 3 is negative 1, and the answer is C. Okay, let's go to question 8. So I brought back the actual test document, okay, because it has a graph. All right, so I want to talk about this on top of on the page. Okay, a particle moves along a straight line. The graph of a particle's velocity v of t at time t is shown above. So this is the velocity graph. Okay, for 0, but for 0 less than or equal to t, less than or equal to m, that's just in between here and here. Okay, where j, k, and l and m are constants. the graph intersects the horizontal axis at t equals 0. So it's crossing right there. At t equals k, right there, and t equals m. And has horizontal tangents at t equals j and t equals l. So we know it's horizontal. There's a horizontal tangent right here. So I would just draw this in, right? We have a horizontal tangent right there. And we also have a horizontal tangent right here at L, okay? For what values of t is the speed of the particle decreasing, okay? Speed of the particle decreasing means slowing down, okay? So, right, doesn't that make sense? If the speed is decreasing, you're slowing down, okay? So remember, how do you know when you're slowing down? It's when the velocity and the acceleration have different signs, okay? So velocity and acceleration have different signs, okay? So we're looking at velocity, okay? So let's talk about the sign for velocity first, okay? So the velocity is positive in between zero and k. The velocity is positive because this is the velocity graph, and the velocity is negative from k to m, all right? So we need to look at acceleration too, okay? So what's acceleration? Well, acceleration is the derivative of the velocity, right? So we would know from the velocity graph, if the velocity is increasing, that would mean the acceleration is positive, okay? So right here, we know the velocity is positive, and because we're increasing here, the velocity or the acceleration would also be positive. So the particle or the particle wouldn't be slowing down here, or excuse me, the speed of the particle would not be decreasing, it would actually be increasing, right? Or speeding up. Now, right here, okay, the velocity is positive, but the acceleration is negative because the velocity is decreasing here, right? Okay, so we're slowing down here, which means the speed is decreasing. So that's one of our intervals. It's from J to K, all right? So J to K, we know where the speed of the particle is decreasing, okay? I have a tough time because there's a couple ways you can say this. You could say the particle is slowing down, and you can also say the speed is decreasing, okay? Now, right here, okay, from K to L, we know because we're below the or the t-axis that the velocity is negative here, okay? But the acceleration is also negative. So what's happening right in here is the particle is speeding up, or the speed of the particle is increasing, okay? So that's not one of them, right? And then right here from L to M, we know our velocity is negative because it's below the t-axis. And we also know that we're increasing here. So that would mean that the derivative is positive here, right? So V of t is negative, okay? But the acceleration is positive. So we have to be slowing down here. So that would mean that the speed of the particle is decreasing here from L to M. So we said J to K, and also from L to M, right? Now, I realize that you could have just said, oh, Mr. Mitchell, it's just this one, right? Because that's the only one that's J to K. Yes, you're right, but you're not going to have multiple choice questions on the test, right? So the correct answer is C, right? So right here, let's write this down, okay? So right here, V of t is less than 0, and A of t is greater than 0. So that's why it's slowing down here, okay? Now right here, I wish I had done this right at the get-go, okay? V of t is less than 0, and we know A of t is also less than 0 because it's decreasing, okay? And then right here, we know V of t is greater than 0 because it's above, and I know I'm decreasing, so that means A of t is less than 0, okay? That's slowing down, right? Because they're opposite signs. And then right here on this interval right here, I know V of t is greater than 0, and A of t is also greater than 0, okay? Let me say something. This is a perfect example that you could not, if they gave you just this without this, right, and just asked you this question, okay, there is no way you're going to be able to look this up. So this is a perfect example of a question they could ask you on the AP exam this year, okay, without it being multiple choice. They could just ask you, for what values of t is the speed of the particle decreasing, and you just have to write, you'd have to write this, okay? All right, guys. Okay, let's go on to number 9. Okay, so for this problem, they're asking you, here's the function f, for which of the following values of x is f not continuous, okay? So you need to know something about these graphs, okay? So right here, x minus 2 is going to cancel, right? That's a removable discontinuity. So it's a discontinuity, which means it's not continuous, right? So this could be rewritten as x minus 2 times x plus 3 over x plus 1, right? Because you can't get rid of the x plus 1, okay? So what's happening at x equals -1, right? Okay, so what we look at here is what causes the denominator to be 0 in this, right? And it'd be x equals 2, and then also x equals -1, right? So the function is not continuous. F of x is not continuous at x equals 2 and also at x equals -1. Now, what's happening at 2 is that's a removable discontinuity. Because f of 2 doesn't exist, right? F of 2 doesn't exist, okay? But you could still find the limit. The limit exists, okay? So the function doesn't exist at 2, but the limit exists, right? Okay, because, and let me go through just continuous. The definition of continuous is that the limit and the function have to be the same, right? So f of 2 does not exist, okay? But the limit as x approaches 2 of f of x, okay, we can actually find because we can put it into this one, right? So it'd be 2 minus 2 times 2 plus 3 over 2 plus 1. Well, this is going to be 0, which is going to cause the whole numerator to be 0, 0 over 3, right? Which is 0. So the limit exists, right? But they're not the same, right? Because the function doesn't even exist, right? So the limit as x approaches 2 of f of x does not equal f of 2 because f of 2 doesn't even exist, okay? All right, so if the function doesn't exist, or the function actually can exist, okay, but if these are different, right, okay, then what happens is that's a removable discontinuity. You know you have a removable discontinuity when the limit exists, okay? At x equals -1, right, okay, that's an infinite discontinuity. So I'm going a little bit more in depth than what the question asked, but I think it's important to review this, okay? Because they may ask you a question like this, because they're not going to ask multiple choice questions, okay? So infinite discontinuity. Why is this an infinite discontinuity? Because it only makes the denominator 0, but okay, so f of -1 does not exist, and you can't remove it because you can't cancel it out. And also the limit doesn't exist. So the limit as x approaches -1 of f of x does not exist. Okay, so let me show you why it does not exist. So this is a one-sided limit. Okay, so we gotta remember when we do a limit, we gotta show both sides. Okay, so the limit as x approaches -1 of f of x, what is that going to equal? Okay, and I forgot -1 from the left, right? -1 from the left. Okay, so a little bit to the left of -1 would be like -1.1. So I'm going to put -1.1 in here. -1.1 minus 2 times -1.1 plus 3 over -1.1 plus 1, okay? So we can actually think of this as being really close to negative. What's happening is this is getting closer and closer to -1, right? So this would get closer and closer to -3. So we'd have -3 times, and this, again, this is getting closer and closer to -1, right? So -1 plus 3 would give you 2. So that's going to give you a negative value. Now this one right here, this is where it's important. This is going to be a number that's negative, but it's close to 0. So I'm going to write a -0 here. Okay, so what happens when you take a negative divided by a negative? That's going to give you a positive, but this is going to get closer and closer to 0. So this is going to be positive, and this is going to be positive infinity. Okay, so as you approach -1 from the left, it's going to go to infinity. And the limit as x approaches -1 from the right of f of x. Okay, so that'd be like -0.9. Okay, so -0.9 minus 2 times -0.9 plus 3 all over -0.9 plus 1. Okay, again, this is not really -0.9. It's getting closer and closer to -1. So you can think of this one being -1. -1 minus 2 is -3. You get the same thing as you did over here. And you can think of this as being -1, right? So -1 plus 3 would be 2. But now this one down here in the denominator is going to, again, be 0, but it's going to be close to +0. So I'm going to put a +0 here. Well, this is going to be a negative number, right? -6 over +0. That's going to give you negative infinity. So this one's negative infinity. And that's why the limit as x approaches -1 of f of x doesn't exist, and why it tells you it's an infinite discontinuity. Okay, that was way more than the question asked, but I think it's important to go through this stuff with you guys. Okay, all right, let's go to number 10. All right, for question number 10, I'm going to go back to the actual exam. Okay, a particle moves along the x-axis with a velocity v of t is equal to 3t squared minus 4 for t greater than or equals 0. If the particle is at position x equals -2 at time t equals 0, what is the position of the particle at time t equals 3? Okay, so that's telling you at x of 0, it's -2. So we know from this right here, x of 0 is equal to -2. And we want to find x of 3, okay? Now, this is, if I integrate velocity, I get the change in position, okay? So I want to integrate from t equals 0 to t equals 3. So if I integrate 0 to 3, my velocity functions, which is 3t squared minus 4 dt, I know that this is going to come out to be x of 3 minus x of 0. This is the fundamental theorem of calculus, right? Because if this is the velocity, the antiderivative velocity is position, which is the x of, okay? It's the position, okay? All right, so now to do this, I know this, this value right here, I know is -2, okay? And I can calculate this one because it's just antiderivatives of 3t squared minus 4. So this would be, the integral of 3t squared minus 4 would be, this would be 3t cubed over 3t cubed over 3 minus 4t evaluated from 0 to 3. And this would be equal to x of 3 minus a -2, because x of 0 is -2, so that's going to make +2 right there. Okay, so this is going to be t cubed minus 4t evaluated from 0 to 3, and that'd be x, excuse me, x of 3 plus 2. Now this would be 3 cubed, right? 3 cubed minus 12, or 3, let me just write it. So 3 cubed minus 4 times 3, and then minus 0 cubed minus 4 times 0 is equal to x of 3 plus 2. Now this would be 27 minus 12, which would give you 15, minus, well, this is just going to be 0, right? So I don't need to write it, is equal to x of 3 plus 2. Subtract 2 and you get 13 is equal to x of 3, right? And so the correct answer for number 10 is A, okay? For number 11, they give you f of x is equal to this integral from 0 to x of 2t cubed minus 15t squared plus 36t, and then dt, okay? And they're asking for on which of the following intervals is the graph of y equals f of x concave up, okay? So concave up would be where the the second derivative is I'm saying concave up. I meant concave down. It's where the second derivative would be negative, okay? So what we have to do is figure out what the second derivative is, okay? So if f of x is this, okay, now this is the fundamental theorem of calculus, okay? If I take the derivative of this, this would be f prime of x, right? So f prime of x. If I take the derivative of this, remember this is just going to be 2x cubed, okay, because the derivative will undo this integral, right? Okay, so this becomes 2x cubed minus 15x squared plus 36x, okay? And that's what the derivative of that would be, okay? And then we got to look at the second derivative, right? So the second derivative, f double prime of x, we got to take the derivative of this, right? So this would be 6, because we've got to bring the power down. So this would be 6x squared. And then minus 30x. And then plus the 36, right? Now, all of these are divisible by 6, right? So that means I can factor it out. Okay, that's going to be helpful. So f double prime of x is equal to 6 times, and this would be x squared minus 5x plus 6. And then that's going to be factorable, right? So f double prime of x is equal to 6 times, and this would be x minus 3 and x minus 2, right? X minus 3 times x minus 2. Okay, now we need to know where the second derivative is 0. It's called the critical numbers or the critical points. Okay, so we got to set this equal to 0. So 0 is equal to 6 times x minus 3 times x minus 2. Okay, and then solving this would give me x is equal to 3 and x is equal to 2. 2. I said 2 and I wrote 3. Okay, so x equals 2. Okay, so this is going to set up the intervals, right? We're going to do a sign chart again. Okay, so the intervals that we're going to look at, okay, and I'm going to look, and there was no restrictions on this. Okay, so the intervals are going to be negative infinity up to the first of these, which would be 2, and then from 2 to 3, and then from 3 to infinity. Okay, now let's write our test point. Okay, so our test point, a good test point in here would be x is equal to 0. In here, x is equal to 2.5. And then in here, x is equal to 4. Okay, and then we're looking for the sign of f double prime. Okay, and then that's going to tell us the behavior of f. Okay, and it's going to tell the behavior, the specific behavior is the concavity of it. Okay, so it's easier to put this into the factored form, right? So this is 6 times 0 minus 3, right? And 0 minus 3, that'd be negative 3, right? So this time I'm going to actually put the numbers in. So 0 minus 3 would be negative 3. And then 0 minus 2 would be negative 2, right? Okay, and this would be a negative times a negative. We really don't care about the numbers again, right? It's a negative times a negative, which is a positive, times positive 6, which is positive. So this is positive. And that would tell me that it's the f is concave up on that interval, okay? So how about 2.5? So we have the 6, and I'm not going to put the numbers in. I wish I hadn't now, okay? But the 2.5, right? This 6 is going to always be positive, so that's going to be positive. It's not about the number value, it's about the sign of this second factor, right? So 2.5 minus 3, is that going to be negative or is it going to be positive? Well, it's going to be negative, right? So negative. And then 2.5 in here, 2.5 minus 2, the sign of this is going to be positive. So a positive times a negative is a negative, and then this negative times the positive is going to give you negative, so this is negative, which would tell you it's concave down. Okay, so on that interval, it's concave down. How about from 3 to infinity? Well, the 6 is positive, and 4 minus 3 is going to be positive, and 4 minus 2 is going to be positive. So we have a positive times, that's going to be positive, right? Which tells you it's concave up. So the only interval in which it's concave down is from 2 to 3, and 2 to 3 only, and that would be the answer for number 11 would be D. Okay. All right, so let's go to number 12. So number 12, I'm back onto the test booklet, okay? And so because I want to talk about all of these, right? So for which of the following does the limit as x approaches infinity of f of x equals 0? So this would only go to 0 for a rational function, and all three of these are rational functions, okay? Or a fraction, okay? I shouldn't say they're rational functions. They're not. They're fractions, okay? All right. So the only way is if the denominator is growing faster than the numerator, okay? So natural log functions, magnitude, that grows the slowest. So x to the 99 as x goes to infinity, this is going to overtake this one. So this one would equal 0 if we take the limit as x approaches infinity. So this it'd be this one. This would be one that's true. Okay, this would be true for. E to the x grows faster than natural log of x, okay? So the denominator needs to grow faster than the numerator for this to happen. So this wouldn't be true. So this would be false. And then x to the 99 over to e to the x. Okay, e to the x grows bit faster than these power functions, okay? Even though 99 is a huge number, e to the x is going to overtake it for some value of x. This one's going to be bigger than this one. Because if you remember when we did this, when we did magnitude, exponentials, and e to the x is an exponential, is almost the fastest growing thing, okay, as x goes to infinity. So this one's also going to be true. Okay, so the only choices for this are 1 and 3, which is E. So the correct answer for number 12 is E. Okay. All right, let's go to 13. All right, for number 13, okay, let f be a differentiable function such that f of 0 is equal to negative 5. F prime of x is less than or equal to 3 for all x, okay? Of the following, which is not a possible value for f of 2, okay? So basically what this is saying is that f of 2 is equal to negative 10, or f of 2 is equal to negative 5, or f of 0 is equal, or f of 2 is equal to 0, or f of 2 is equal to 1, or f of 2 is equal to 2, okay? All right, so this actually is a test because all the derivatives have to be less than 3. This is actually, if you find the average rate of change, okay, between these 2 points, all right, there's a derivative in there between 0 and 2 that would be the same value as that. And what we're saying here is that all the derivatives have to be less than or equal to 3. So I'm going to grab my paper and we're going to work through this, okay? So basically what we have to do for number 13, okay, is we have to find, okay, each of these. So what's f of 2 minus f of 0 over 2 minus 0, okay? So this is the mean value theorem. So if you do this, then there has to be a value because it's differentiable, and if it's differentiable, it has to be continuous, right? Okay, so there has to be some derivative, f prime of, let's say, c, okay? And this c has to be some number between 2 and 0, okay? So what we know is that all of these derivatives have to be less than or equal to 3. Okay, so if we do for part A, okay, if we do f of 2, okay, so f of 2, we're saying it's negative 10, so that'd be negative 10 minus f of 0, which we know is negative 5, over, and to make this quick, this denominator is always going to be 2, right? Okay, so this is going to be negative 10 plus 5, which would be negative 5 over 2, and that's negative 2.5. Well, that's less than or equal to 3, right? So that one works, okay? That one's true. So now we have to look at part B, okay? So we're saying for part B, f of 2 is equal to negative 5. So for the slope, that'd be negative 5, okay, minus negative 5 over 2 minus 0, which would be 2 again, right? And so this would be negative 5 plus 5, which would be 0 over 2, which is 0. Okay, so that there's a derivative here that has to be less than 0. That's between 2 and 0. Okay, and so for C, All right, we're going to do f of 2 is equal to 0. Okay, so that would be 0 minus negative 5 over 2. So that'd be 5 over 2, which is 2.5. Okay, that works, right? Okay, because just we're checking to see which one would cause it to be not less than or equal to 3, okay? And then for part D is saying f of 2 is equal to 1. So that'd be 1 minus negative 5 over 2 minus 0, which is 2. And so that'd be 6 over 2, which is equal to 3. Okay, that's fine because the derivative, remember the mean value theorem says there must be a derivative that's the same as this, right? So there has to be a derivative that's 3, okay? All right, and then for part E, okay, for part E, we have f of 2 is equal to 2. So that would be 2 minus negative 5 over 2. Well, that would give you 7 over 2, which is 3.5. Well, they're saying that there's if f of 2 is equal to 2, you're saying that there has to be a derivative in there that's 3.5. Well, what does it say? It says that all the derivatives for x have to be less than or equal to 3. So the only one that it can't be is this one right here, which is f of 2 cannot be 2, because we'd have to have a derivative that's bigger than this value right here. Okay, so that's the correct answer for that one. Okay, so now let's go to 14. For 14, they're giving you the function f of x is equal to x plus b when x is less than or equal to 1, and ax squared when x is greater than 1, okay? And they're asking for the values of a and b for which f is differentiable at x equals 1, okay? So for differentiability, okay, you have to be continuous. So you have to be continuous, and we also want it to be differentiable, okay? All right, for it to be continuous, we have to take the limit as x approaches 1 from the left of f of x has to be the same as the limit as x approaches 1 from the right of f of x. Because x equals 1 is where it's switching, okay? All right, to be differentiable, okay, we're going to take the derivative of this, okay? So f prime of x is equal to, okay, so this is a piecewise function, okay? Now a and b are constants, okay? So the derivative of x plus b would just be 1, okay? So it's going to be 1 when x is less than 1, okay? Now we don't know whether to include less than or equal to or just less than, okay? So we want to leave it as less than, okay? All right, and then from right here, this one, the derivative of this one would be a times 2x, or 2ax when x is greater than 1, okay? Now, for it to be differentiable, these two, the limit as x approaches 1 from the left would have to equal each other, okay? So to be differentiable, the limit as x approaches 1 from the left of f prime of x would have to equal the limit as x approaches 1 from the right of f prime of x, okay? Those two derivatives have to be the same, okay? So if we do this, okay, for f of x, this one, because we're choosing x's that are to the left of 1, that'd be x plus b, okay? So this would be the limit as x approaches 1 from the left of x plus b must equal the limit as x approaches 1 from the right, which would be ax squared. Okay, so what we're going to do is we're going to put 1 in here because we can do that. So this would be 1 plus b would have to equal, and then this one would be a times 1 squared. Okay, so that'd just be 1, right? So 1 plus b must equal a. Okay, now from over here, all right, if we do this one, okay, the limit as x approaches 1 from the left, well, this one would be this one, which would be 1, okay, and this would have to equal the limit as x approaches 1 from the right of, now when we're using x is great, when we're saying to the right of 1, that means x is greater than 1, so we have to use this function. So 2ax, and this is saying put 1 in for x. So this means 1 is equal to 2a times 1, which means 1 is equal to 2a, which means 1/2 is equal to a. Now coming back over here, okay, now that I know a is 1/2, for it to be differentiable, a has to be 1/2, okay? Over here, our b, because it needs to be continuous still, 1 plus b would have to equal 1/2, right? Okay, so that would mean if I subtract 1, that would mean b is equal to 1/2 minus 1, right? Or b would equal negative 1/2. So a would have to be 1/2 and b would have to be negative 1/2 for this to work. And so the correct answer for number 14 is A. All right.